Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss how to improve the machine learning performance using Ensemble Learning. Ensemble Learning helps to improve the machine learning results by combining several models. This approach allows the production of a better predictive performance compared to a single model. The basic idea is to learn from a set of classifiers and to allow them to vote. There are three methods for ensemble learning. The first one is bagging. Build multiple models from different subsamples of the training dataset. The second one is building multiple models, each of which learns to fix the prediction errors of a prior model in the sequence of models. The third method is voting. Building multiple models and simple statistics are used to combine the prediction. We'll start with the first method, that is bagging. It's also known as bootstrap aggregation. It involves taking multiple samples from training dataset and training a model for each sample. The final output prediction is average across the predictions of all the submodels. The three bagging models which can be used are bagged decision tree, second random forest, three extra trees. You can see here when we go for a single iteration what our results are. In case of bagging, we are using multiple algorithms parallelly. Now, how we can do this? Let's see in Jupyter Notebook. From pandas, import read underscore CSV. From sklearn.model underscore selection, import the k-fold. From sklearn.model underscore selection, import cross-validation score. Now, we will require bagging classifier. So import the bagging classifier from ensemble, from sklearn.ensemble. From sklearn.tree, import the decision tree classifier. Here we are specifying the file name, that is a Pima Indian Diabetes. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series. Names are of the variables. Data frame is equal to read underscore CSV. So here I am writing file name. So it will fetch the data from here. Names is equal to names. So the data will be fetched from here. The variables will be picked up from here. Array is equal to data frame dot values. Now I'll segregate the data into independent variables and the dependent variable. X is equal to array colon 0 is to 8. Y is equal to array colon 8. By specifying the seed, I will be able to reproduce the same result every time. K4 is equal to K4 number of splits. 10 random underscore state is equal to seed. Shuffle is true. Cart is equal to decision tree classifier. So I'll be using the decision tree classifier. The number of trees which I'm considering in this case is 100. So bagging model is equal to bagging classifier. Base estimator is cast. Number of estimator is equal to number of trees. Random state is seed. Results is equal to cross validation score. Model, it will be picked up from here. Model X, Y, CV. Cross validation will be done according to the K4. And I got the result 0.757. It will increase the classification accuracy. So this is the first method of bagging. The second method, which is a random forest classification. Everything will remain same. The thing which we require now is random forest classifier library is necessary. Another thing which we will change is the model is equal to random forest classifier. Number of trees are 100. Maximum features which are to be extracted is 3. K-fold remains same. And here model is equal to random forest classifier. Number of estimators is equal to number of trees. Maximum features is equal to maximum features. Results is equal to cross validation score model X, Y, CV, K-fold. Again, I'll print the results and I got the classification accuracy 0.77, which is more than the bagged decision tree. Now, we will introduce some more extra trees in the previous algorithm. So, adding extra trees for the classification. How we can do this? So, number of trees are 100. Maximum feature is 7. I'll specify. So, number of trees are 100 and the model will be prepared on the basis of extra trees classifier. Make sure that you import the extra trees classifier from sklearn.ensemble. Everything else will remain same till here. The only thing which will change is extra trees classifier. Number of estimators is equal to number of trees. Maximum features is equal to maximum features, which are 7, which are to be extracted from here. Results is equal to cross validation score model XYCV. Cross validation is to be done according to the key fold. This time I got the result 0.77. So these are all bagging algorithms. Now let us go back and try to understand what is a boosting algorithm. In this case, it's a sequential method. First, the data is trained according to the first classifier. The output is again fed to the another data, that is another training data set. Again, another classifier will be used. So this is a boosting algorithms. Two boosting algorithms which are used which are very popularly used. One is adaboost and second one is stochastic gradient boosting. Now how we can do this, let's see in Jupyter Notebook. So everything else will remain same till here. Make sure that you have to import the adaboost classifier. Again, everything will remain same till here. Number of trees are 30, seed is 7, k-fold, 10 splits are there, random state is equal to seed, so seed is 7, shuffle is equal to true. Here, I'll be using the adaboost classifier, where number of estimators is equal to number of trees. Random state is seed. Again, I'll generate the results with the help of results. Results are equal to cross validation score model XYCV. Cross validation is to be done according to the key fold. Print the results. I got the classification accuracy is 0.755. So here my results are comparatively, the classification accuracy is lower than the bagging algorithms. Let us go for one more algorithm which is known as a stochastic gradient boost classification. Make sure that from sklearn.ensemble you import this library gradient boost classifier. Everything else will remain same till here. Seed is 8, you can keep it 7 also. Number of trees are 100. The only thing which will change here is gradient boost classifier. Everything else remains same. And print the results. I got the result as 0.744. Again, my classification accuracy has decreased. So this is the second way, that is boosting algorithms. Now we will see the third method in which we can improve the performance of machine learning algorithms. This is known as voting ensemble. It is one of the simplest ways of combining the predictions from multiple machine learning algorithms. It works by first creating two or more standalone models from your training dataset. A voting classifier can then be used to grab the models and average the predictions of submodel when asked to make predictions for the new data. Basically, we are voting for an algorithm. The algorithm which gets maximum votes is considered to be the best algorithm. Let's see how we can do this. Again, we will go in Jupyter Notebook and here, voting ensemble for classification. Everything else remains same. Make sure that you this time you'll have to import the decision tree classifier, support vector classifier, and voting classifier. It is again in sklearn.ensemble only. Everything else remains same till here. The additional thing is now we have to create the estimators, the nested model. So estimator is equal to square bracket, model 1 is equal to logistic regression 1. Estimators dot append logistic model 1. Model 2 decision tree classifier. Estimators dot append cart model 2. Model 3 is equal to support vector classification round bracket. So three models have been considered. Three algorithms have been considered. Estimators dot append support vector machine model 3. Now I want to do the voting classifier. So ensemble is equal to voting classifier estimators. So it will start from here. Results is equal to cross validation score ensemble XYCV cross validation according to the key fold. Print the results. So we got the result here. The classification accuracy here is 0.768, which is considered to be lower than the bagging algorithms. But this is the way one can improve the performance of the machine learning using three different methods. All these codes are given in the book Machine Learning Mastery with Python, written by Jason Brownlee. For more videos on machine learning using Python, kindly subscribe to my channel. You can see my playlist in which I've already uploaded many videos related to machine learning. Please don't forget to press the like button. You can also follow me on LinkedIn and Twitter.